In this tutorial we are going to connect a few resistors 6 different ways. The most trivial way is to use the wire tool and simply draw a wire net that connects the terminals of the two resistors. The resulting net has a dummy anon net name because it is not explicitly named on the drawing. Nevertheless, it contains the two terminals we connected graphically. Another way is to connect by net name. Draw two separate wire nets, each connecting two terminals. This will result in two nets in the abstract model. Now name them both, using the same name. There's now only one network in the abstract. Different wire nets with the same name are merged during compilation because of the matching name. Our drawing is confusing because there is no hint that the two wire nets are the same net. It's best practice to create a floater for every named net. Connecting by net name can be used to make net name based connections by placing short stub wires and naming them. A purely data-driven way is to use a symbol attribute. The attribute is called connect and is an array kind of attribute. Use the attributes dialog over the symbol, create the connect attribute with empty value and convert it to array. While the connect attribute is selected, click on the assisted edit button. This brings up a table with all the attribute connections of the symbol. These connections are made between a terminal name and a network name. Fill in the form and click on Add/Edit to create a new entry. Repeat the process on the other resistor using the same net name. After auto-compilation, the abstract model features the new network and the two resistors are connected, even though there is no graphical hint on the drawing. Such attribute-based connection is often used for hidden connections to avoid visual clutter. For example, the power and ground terminals of ICs can be connected from the symbol attribute. These methods are not exclusive and can be combined. For example, a third resistor can be added to the same net using the named wire stub method. As long as the net name matches, it doesn't matter how it is specified. The terminal is connected to the same abstract network. A very common connection is to a power rail like VCC or to the ground. The shorthand for this are the VCC and ground symbols. These symbols come with a single terminal and a connect attribute configured to connect this terminal to VCC or ground. The anonymous components showing up in the abstract model are the VCC symbols. Since the VCC symbol doesn't have a footprint attribute, it will not show up as a component in the netlist using the PCB target. The standard library has such symbols for the most common power rails, but there are always cases with special power rails not covered. Such cases can be handled using the generic rail symbol. It works the same as VCC, except it has a rail attribute that determines the net name it connects to. When you invoke the attribute editor over the rail symbol, make sure you are not over the terminal, because that way the attribute editor is opened for the terminal. Make the grid more dense, and have the crosshair next to the terminal under the horizontal line of the symbol. That spot is still within the symbol, but is not on the terminal.